It's project time, and by popular request, every time I feature the ionizers, people say, can you show us how to make one? Well, by using this very common Chinese module that is used in air conditioning equipment, it's called a PKA22F, and it's got a universal voltage range 110 to 220 volt. Well, you can also use it on 240, but I'm going to add a couple of resistors for this. However, this module makes things a lot easier, and it just means you can either use this stylish 3D printed case, which has the script down, the description down below, or you can just use a standard plastic project case to make your ionizer. The choice is yours. Now, there is the script for making this case. It comes in 3 parts. It's got the base with the module area that you can just basically sit the module into there. It's got the cable restraint. It's got a little washer that goes on over there just to hold the cable down for that cable restraint. And it's got the top, which has a cone with the 2 screw fixings, the cable entrance point, and it's customizable. And it's got the little tip here for the carbon fibre emitter. Now, if you choose to go the route of 3D printing it, you have some options. This all depends if your module is standard sizes. So just to allow for this, because I know sometimes things go wrong and you end up with something a different size, this area here, the bit that actually holds the module, this bit here, you can change the size of this box and it'll scale it up within reason. So you've got some variables at the top of the script here, box X and box Y. The widest side of the iron module, this side is the X dimension, and the Y dimension is that dimension. And you can just type that in, you can fine tune up and down until you get a nice fit. You also get to adjust the thickness of the base. Now, the standard base thickness is 1.6 millimeter to match more or less the rest of the case. However, when you're just prototyping, you're just testing sizes, you might want to make that just 0.4 millimeter or something like that, just for a much faster print, so it gets straight onto the bits you're interested in. Largely, this little box that you're going to put your module into. The other part of the script is, I should mention what this is. The cable is going to loop around this and then go inside, and then the washer's going to hold it down. This is a cord restraint. It's just all built into the script. The other part of the script that you can, well, the second script is for the ionizer top. No, that's fine. Now, things worth mentioning. You've got 3 variables, base, cone, and hole. The base is the height of this bit down here. If you somehow end up with a very tall module and you need a bit of extra space, you can extend this base up the way. The cone, you can choose the height of the cone, that depends on your printer. But in this case, cone 100, I made about 4 inches high. So you get base, cone, and hole. The hole is the hole in the end for your ion emitter. It will just scale this up. You can actually just make it any size. I wouldn't recommend making it huge. It's really, you want to just have it so that your ion emitter just sits down nicely into it. I find 2.5 millimeter for this is okay. Murphy's Law says it probably won't fit and you'll have to drill it out, but that's what happens. The other script down below is just for making the washer. It's a very, very tiny script. The washer is purely to hold the cable down and in position. It's not taking any of the strain relief. But you'll see this when we go into the process of making this. So let's make it. I'll bring the focus up to a sensible level. So I should have got a glue for this. Here is the iron module. And let's start by putting the cable in and locking it into position. So the way the cable goes in here, you want to just put a loop in it, and it goes in like this. And then you want to leave enough that when this end comes round like this, fairly tight bend, it's just got a good decent amount free. It's just kind of, you know, you'll just play it by ear, so to speak. Once you've done that, take your washer. I should have got a screwdriver here for this. This screwdriver will do. And take this screw. Now, the screw sizes I've sized it for are imperial. Just because, like, they give the measurements in millimeters, but they're actually imperial. So this is a 1/4 inch by 4 screw. So that goes through the washer here. And it goes into, I'll zoom down this just so you can see it better. And it goes into here, and as I say, it's not taking any of the strain. All it's doing is basically clamping the cable down, just stopping it from popping out. The real strain is taken by the pillar in there that's going to stop that dragging out. Hopefully. Now, I'm going to connect the live neutral to these wires. If you're in a country like 100 volt for Japan, 120 volt for, well, America and other countries, then you can just connect these wires directly onto the ionizer module. Just kind of leave a bit of space, but you've got loads of room in here just to actually make that connection. However, I am going to add a couple of resistors and some heat shrink sleeving. So I'm going to stagger these connections, just so there's no risk of the two connections shorting together. So I'm going to stagger them a little bit. And I'm going to strip them. I shall use this little dinky draper stripper for this. Put it into a random hole that looks roughly the right size. Something has avalanched in the vicinity. That is because I was trying to find a size of heat shrink I needed. And disturbed my huge gadget mountain, and now it is avalanching at every opportunity. This is what happens when you lead a cluttered technical life. A glorious cluttered technical life. So because I'm adding these resistors in, I'm going to use two 10k resistors. You could use 10k to 18k. The point of these is just to take a bit of strain off the little resistors that are in here at our higher 240 volts. Strictly optional. You could just use it at 240 volts if you wish. So I shall crop these leads down, and I shall tin them with solder, and I shall stick them on. I shall also tin these leads, keeping them well away from the other stuff while I do so I don't melt the cable. I will just basically flow some solder onto this connection and this connection. And I shall unbury the cable of the solder iron from under plastic fake neon. And I shall put a little blob of solder on the end of these resistors. 1 and 2. Because I'm going to sleeve these, I have to now solder these on, and then I have to leave these ones a bit longer. And then when I've soldered them on, I'll put the sleeve on first and then slide it down. It's perfectly permissible to completely forget to put the sleeve on first and then have to do it all over again. That happens even to veterans. So let's reflow that. And reflow this one as well, to lock our resistors in position. In position. Shall fold that one out the way and fumble and mess, see if I can mess this up. Most fumblesome. This is where some little jig for holding that in place would have been nice, but we don't have one, so that's fine. Now I'm going to crop that little solder spike I've left in the neutral one. Not my finest work, that's fine. Watch me mess it up even further now. That's fine. And I'm going to crop those wires, the leads down a bit more and solder the red and black wires on. But before I do that, I'm going to get a rough idea of length. So this is going to be coming up over here. It's going to be folding over there. They're going to be going like that, going like that. Plenty of room. And I shall crop these, put some heat shrink sleeving on, sized to go over those resistors, and have a bit of margin spare. So I'm going to be generous. I'm going to make it about that length. For those who wonder what this is in the first place, an ionizer presents a very high negative voltage at very, very low current onto a cluster of sharp points, in this case the carbon fibre emitter in the top, which just turned out to be a great way of making an ionizer emitter. And that results in an electrostatic charge being put into the air, which helps precipitate dust out. They're all sneaked into modern air conditioning equipment and air filters. The HEPA filters all have them. Usually as a luxury extra feature. All you get is a module that costs a couple of dollars and a button to turn it on. That's pretty much what you're getting for that extra feature. But it does increase the effectiveness of filters by putting a charge in the air, and also in this case it will just make dust and dirt in the air precipitate out to any grounded surface, which is actually any surface in the room like this table. Makes a mess, but is it better on that surface where you can wipe it up or in your lungs? That's the question you may want to ask. This is where the contrarians, the negatarians, the negative people who always make nasty comments about things, claimed that ionizers actually made the dust stick inside your lungs. There's no evidence of them ever doing anything like that at all. They come up with the strangest theories and then present them like scientific fact. There are also quack sellers who claim their ions are smaller, they're not, and are therefore ingestible. Like you can actually, eat them. It's like, what? So I'm going to connect the black wire to the blue wire here. Really, it doesn't matter which wire gets connected where. Obviously, you don't want to connect them all together in one big, huge clump, though, because then that would make a very big bang. And then we'll get this one, and we'll hook this wire onto here. And that will be our mains connections done once the heat shrink is applied, which we're about to do right now. The lighting here is all geared up for the camera. It's not geared up for me. Maybe I should do something about that. So I'm going to slide the heat shrink down so it covers both bits of wire with a good generous margin. And then I shall heat it and shrink it on. Once again, this is optional if you're in America. You don't need to do this if you've got a 110 volt supply, or every other country with a 110 volt supply. And the unit is theoretically rated for 220 volts. So theoretically you don't need to do this at all, but I feel it's better if you're on, say, a 240 volt supply. General European power. Just because it may take a bit of the strain off the ionizer and make it last longer. It may result in slightly less ionic output though. So it's entirely your call. You do what you want to do. It's your project. That looks alright. These are going to end up stuffed up inside the pillar, which is fine, because now we're going to do something despicable. This is the high voltage wire. The reason it's high voltage wire is simply because in the commercial units it might be bunched together with these other wires. I've just seen them tied together in clumps. It's not the best way to do it. It should be kept well separate. However, I need the full length here because I'm going to actually feed this from the outside of this down and into this unit. Hopefully that is going to fit in. I'll find out in due course. So I need a good length here, and then I'm going to add a 1 meg ohm resistor. The reason I'm adding a 1 meg ohm resistor down here is because I just want a bit of extra electrical separation, because the separation inside these modules from the mains input to the little tuft of carbon fibers is very minimal. And I just think it's good to finish the job and, you know, add safety features. So what I'm going to do is I'm going to strip this, and then I should have tried this first. Feed it down the inside. Let's tin this before I do that. It's going to make it a little bit easier. If you want to extend the wire, you can have the high voltage going up to a certain level inside the unit, or just sleeving and then just stuff. You can use low voltage wire from above this point here inside, just if you want to actually do that. If you want to make a super duper tall ion cone, which would be nice. So this fits in there nice. It'd be really nice if this was a friction fit. It's not really a friction fit. It's not going in at all, is it? Right. Can I shrink this down a little bit more? Hold on, let's see if I can shrink this heat shrink down. It just feels that little bit wide, but it might not be. I shall try this. I may just have to reamer that hole just a tiny little bit more. The prototype, the last one I made for a friend, it fitted. This one did not. Murphy's Law. Let's try that again. Is it going to fit in? No, I will have to make that wider. Okay, right, tell you what, I shall taper it slightly by ramming a screwdriver in the end. This is not going to end well, is it? What size is that? I could just measure it with the calipers, couldn't I? The last one was 2.5. This one is 2.6. It's just that tiny bit too big. Well, tell you what then. I shall grab a set of micro drills. Are there any of these going to be suitable size? And I'll go for... It jumps from 2.5 up to 3. Not great. What if I reamer it very gently with this drill in a suitable... Right, tell you what, I'm going to give it a reamering. A right good thorough reamering. If it ends up too big, you can add a spot of glue there. Let's get this drill into the cordless drill and give it a very gentle reamering. Is that going to work? Is that going to make it fit? Yes, it is. So now that pushes down till it hits the crimp. That's our little carbon fibre emitter on the top. And the wire inside is just enough to get our resistor soldered onto. Okay, I shall just get that drill out the way. And put my default 3mm drill back into the gun. Like that. And stick it right back onto the bench in its usual place. So here is the high resistance 1 megohm resistor that I'm adding in line. Really it's just between you and the mains, just in case somebody touches the tip of this, because I don't really trust the Chinese electrical separation standards. Well, they don't have any electrical separation standards apparently. Well, not in many of these products. Then again, to be fair, this module is designed to be used inside air conditioning equipment. So now I'm going to get a bit of sleeving and I'm going to size it for about, I might just leave that full length. You know what? I will leave that the full length. I will leave that the full length, that's fine. So I'm going to start by soldering onto the emitter connection. How's the length of the video doing? 17 minutes, that's not too bad, is it? It's not going to turn into a monolithic video. And this is where it gets a bit tricky, because I don't want to melt my lovely 3D printed case by sticking the soldering iron up against it accidentally. I've just dropped the resistor as well. Splendid. Good job. Right, hold on. I shall fumble this. I shall put my fingers precariously close to the iron, and then I shall just flow the solder again. Give it a few seconds to cool down. That looks good to me. And then I shall get the heat shrink sleeving and just pop it over that and just shove it right up out the way along that wire. Now, I'll flow a bit of solder onto this end and solder onto the module. This is where I should have had glue handy for putting the module into the case in the first place. I can do that. I can go and get glue. Oh, that's a bit messy, not to worry. And we shall reflow these things together. So there's the high voltage output from the module going on to the resistor, which is optional again. It just depends how close to the edge you want to live. Now that bit of heat shrink slides back down and it covers that, and then I precariously try, I may not use the hot air gun too far up into the 3D printed case in case I melt the case itself, but I shall melt this down now with the hot air gun. This may take a moment. The large overlap of the heat shrink here will also help with the electrical separation, because it does operate at fairly spicy voltages. It works in the region of about 4,000 volts-ish, maybe a bit higher. depends on how easily it's ionizing the air. Right, let's try this. Let's see if the whole 3D printed case malforms explosively and then ceases to be the correct shape. This is looking very good, but I do need that. I do need that glue now. In hindsight, I could have made that lift a little bit higher just to make this hold in place, but that's all right. Oh, incidentally, I've got another one here. The script, the height of the cable restraint, this box, I've reduced it to the same height as the cable restraint, just because I just thought it didn't need to be as tall, and it'll save a wee bit of time printing. I'm going to go and grab some glue. One moment, please. I have applied some Yoo-hoo glue onto this, squished it in, and then taken it back out again, let it sort of like dry off a bit, because this is contact adhesive. It's the rubbery adhesive that once you've let it sort of cure a bit, then when you put it in, it should theoretically just stick solidly, and that will gradually liberate its last solvent out until it's ready. Now comes the lid. So now we're putting the two together, and there is a nice little dome here for the a little arch for the cable, and this should just fit on like this. How good is that? Takes very little adjustment to make it fit. And these screws are number 4s again, but this time they're 3/8 inch. I think they call that, what do they call it? Is it 9.5 millimeter here they call this? This is where I wonder if the little pillar supports could have been better. Not sure. I also would suggest putting, because the screws stick down a bit, I would suggest putting little rubber feet on the base of this. Now, did I remember the disclaimer that this project does operate at mains voltage and could burst into flames and kill everybody, so you make it entirely at your own risk. There, I've done it now. We need to do that these days because of lawyers and their endless desire for money. So let's put a foot about there. These little rubber, standard little rubber stick-on, well, vinyl-y type stick-on feet. I buy them in sheets. They're quite useful. And I recommend using 3 so it triangulates and it sits down on 3 instead of wobbling on 4. And now we can test it because that's the project done. It would have been nice putting little indents in here, but unfortunately, because this is printed with this surface down, it would have been nice to build feet in, but I've just added rubbery feet, that's it. It's also extremely light. The cable may have its wicked way with this, because if the cable's got any rigidity, it will potentially make it, it will drag it about. You may, maybe the correct answer there was to add another compartment and put weights in it like the Chinese do in their products. Anyway, I'm going to plug this in now. Oh, you do get 12 and 5-volt versions of the ion modules. I don't recommend them. Fine for a vehicle where the whole chassis is at negative, but not with, say for instance, let me just grab one, not a plug-in mains adapter, because this generates a very high voltage with respect to ground and puts the charge in the air and creates a differential, and it can actually damage adapters like this. So I don't recommend the low voltage ones. However, let's test our ionizer and see how we're getting on. So I'm going to set this to 20 volts and I'm going to turn it on. I'm going to put the negative lead onto a grounded surface. And I'm going to hold this in front of the emitter, and you can see the voltage is shot up on the ionizer emitter, on the other lead, just without actually physically touching it. And it's showing several negative volts, -8 volts, that's pretty good. And this thing is creating a gentle ionic breeze. I can actually feel that cooling effect and the moist palm of the hand off it. And this is now sitting, putting a charge into the air. Let's test its power. Let's bring in a suitable meter for this. So here is the anti, which is just that little bit better at the super duper low power devices. The Hoppy is still here, it's just better suited to higher power loads. And we'll plug this in and see what its power consumption is. Not expecting an awful lot. Is this going to fit even? 1 milliamp, 0.3 watts of power, 0.8 power factor, that doesn't really matter, but basically speaking, much less than half a watt of power, so pretty much negligible. You can just leave this running 24/7, which is how you should use an ionizer anyway. Ionizers are very, very low power. The classic ionizer that we use in Europe, the ones based on a voltage multiplier, they are so low power that it's pretty hard to even measure the power consumption. The neon indicator in them uses more power. That would have been nice in here, wouldn't it? A little neon indicator inside. That's maybe something for the future. But there we have it. You wanted a custom-built ionizer. Here it is, in a customizable case. The scripts are down below in the description, and as always, it is a mains voltage project. Only proceed with it if you're totally comfortable working with mains voltage, and that risk is with you, but worth it really, ultimately, for a nice, stylish little conical ionizer in your choice of colour.